let's start again. Another presentation for today, but at least it's the last one, and it's about another topic this time, because now we continue. Project part 2. So, overview, then point 2, how to get started. This is the aim of today, like get familiar with the software, install everything, download the model files. And then I give some glimpses to the project description. We will upload the project description during the day tomorrow. And the summary of what is expected from you in the second part. So, you know this chart already, Alicia was showing this to you, the overview about the project. So, we were doing in MATLAB building the MATLAB typical period presentations today. Now we move on to the utility models. Actually, we come to this later. So the utility models, which are then also going into the ME-454 model, which is all in AMPL. And this is what we start today. So the next language we propose, AMPL, is actually used in the next presentation, but also is going to be the central model you have in the end is also going to be in AMPL, and the NLP part of the third presentation is also AMPL. So it would make sense to get familiar here. AMPL, I don't know, it's not very familiar, but it's a very powerful mathematical programming languages, which is able to solve quite large-scale problems with integer variables, both linear and nonlinear. What is typically for AMPL is that the model is spread into 3 types of data files. You find the first data file, which is not data file, the first file, the main file is some file.mod, which is containing all your constraints. The objective function, model constraints, everything. So you set up your model in the .mod file, and then you can give input into parameters, different parameters. For example, every building has other parameters, but is based on the same model. You would declare these input parameters in the .dat files. And then the third one is the .run file, where you, for example, call the solver, set some solving constraints, commands, displaying, printing commands. You could all do in the run file. So you're asked, more information, unless you created an awesome AMPL tutorial. It's already uploaded. This is actually serious. This is not a joke. So it's uploaded on Moodle, AMPL tutorial, and you have a video and also some information on slides. But there's also a free book to AMPL available online, which you can just double check. You have more questions. So next step, what you have to do is also go on Moodle, check the AMPL installation files, install according to your operating system the correct AMPL installation, but all the instructions are in the README file, also online. Project files, what I was talking. So we give you, for this part, an initial model, which is already running. It's very basic, so all the parameters are not the one which are going to be the ones in the end, so you have to develop this model, but this model is running already. It contains, I would say, like the 3 main file, which is one.mod, .run, and what is missing, .dat file, with the whole model. And then we also gave you 2 examples for buildings and 2 examples for utilities, which are only exemplary. This is not anything linked to the APFL building yet. If you have installed AMPL and download all the project files, you can execute, or you have to call AMPL on your terminal or command window and name the .run file and to execute the model. So far to this installation. What are we actually trying to do now? So the overall aim, which you are very familiar with, is we want to design an energy system of the EPFI campus. This is we will also look into, of course, the buildings you have done so far. So also for the next step, it's important to realize which building, for example, is maximum, which is minimum supply temperature. So we include all the buildings, but with the aim to replace the existing energy system and find the cost optimal solution for EPFL in terms of total cost. This is some background. So we have the EPFL campus, and we have 2 temperature loops, one medium, one low temperature. So on this one, you know which building is connected to which temperature loop. And for each temperature loop, we have one heat pump, which is using the lake of Geneva Lake, and another cogeneration unit, which is an oil-fired gas turbine. So here again, so you are actually already getting these main files, which is moyes.mod.dat.run, which is going to be like the core model of this project. So you get this now. But you are asked now to include what you already did and to develop energy utility models. So the first step for the project description, or let's say the second, because first you have to install AMPL, but then the next step is that you use the results of the first part, meaning building characteristics like KTH sun, KT thermal. You use the results of the clustering, like the time steps, the weather data, and include it into the model. And as a step 2, you're asked to develop your own utility models, but all the details are in the project description. We don't go into how you do it in detail now, but yeah, I think that's more or less it. Okay, so in the end, what you're going to present some, but this is also in the project description. So in 2 weeks, you're presenting what is the demand of the whole campus. So you're asked to include all the buildings. I don't want to see, building specific characteristica, but from an energy system perspective, what is the heat demand, high temperature, low temperature, and electricity demand for the campus? What utility did you choose, and how did you model it? And the last one is the evaluation of the optimization results, which is then the content of your presentation in 2 weeks. That's more or less it, but do you have any questions? Yeah?
So we have to export data from the MATLAB file of the first node.
Yeah.
Into the,
yeah. So wait.
In which format we have to export?
So yeah. So in the project description, we give you actually the data you should use for the presentation, just to make it that all of you use the same time steps and the same building characteristics, so we can actually compare your results on the utility side. For the report, you can choose what any data you would like, but in the project description, we show you how you would, in theory, include the data into this model. But this is more or less, you have to, for example, build a building data file where you just put, KTH sun and KT, like 3-4 values, manually tapping.
So we have to use the value on the presentation of 5.2, or the value that we get from the file? Instead that we have already the value in the presentation.
You can answer. Maybe
so
it's more
in the project description that you are going to receive, you will have a list of all KTH and KSUN for each building, and you will have to use those. Because at the end in the model, you have to model all the buildings, like all the 24 buildings of the EPFL, not only the 4 that you were assigned with at the beginning. Okay, so you use those data and you type the data in manually into the DAT file.
So the previous work that we did.
So the previous work, at the end, in reality, you are free to choose whether to use your previous work or not. But since here, at the end, it's good that we have a way of comparing the results between different groups. In order to compare the results, you have also to start with the same data, right? With the same basis. And we provide this basic data that everybody should use. But if you really want to use your way of clustering, like your typical periods that you found, you're free to do it.
Yes. So,
But normally we give you already the typical periods with the frequency and with the temperature and irradiation for each of the periods. Okay, so that everybody can start with the same.
So for the presentation, we would ask you to use actually the data we provide, so we can discuss in class and compare. But if you choose in the report in the end to go the extra mile and put your own, you're free to do it. Yeah? Do you have any more questions? I think they will come by installing and looking into the model.
Yes. So today, as Luis said, we just used the session to install AMPL, to understand the model that we provide to you, which is in the Moodle. And actually you will try to run it and fix the error. I mean, there is not much time left. And tomorrow you will get, we will upload in the Moodle the project description of this part, and you can start working on that.
I think there was an error in the run file because it had 2018 because the ME has 2018.
The name of the file, yes, might be. Yeah. But it should be the correct one, I guess, even though it's 2018. Yes. Okay. Okay, good.